Alright, so in this video we go over section 12.2 arithmetic sequences. So an arithmetic sequence is a special kind of sequence in which every term, every subsequent term has the same difference from the previous term, so that's what we call a common difference, so and recursively defined, well, if you recall this notation from the previous section, we did a couple of examples in which we use these recursive sequences, recursively defined sequences. Well, so the next term relies on the previous one plus some difference. And this difference is always constant, never changes. So for example, how can we tell that we have an arithmetic sequence? For example, what we do? Subtract 6 minus 4. That's going to give us a 2. Subtract egg minus 6. That's 2. 10 minus egg, that's 2. If you notice, we have the same difference for every single term, So in this case, the first term, a sub 1, and the first term is 4, and the common difference in this case is 2. So those are the two elements that we look for in an arithmetic sequence. So arithmetic sequence, they're going to look like linear expressions, like this 3n plus 5. That's another, it's going to be an arithmetic sequence. But in this case, they're asking us to show that the sequence is arithmetic. So in this case, we're going to use this form right here. We will want to show that. So a sub n minus a sub n minus 1 equals to d. All right. So we are going to evaluate a sub n and a sub n minus 1. So what do we have? A sub n equals to 3n plus 5. A sub, and it might want to use a different color. A sub n minus 1, that's going to be 3 times n minus 1 plus 5. All right. And if we keep simplifying this, a sub n minus 1, that's 3n minus 3 plus 5, which equals to 3n plus 2. So we want to evaluate a sub n minus a sub n minus 1. And in this case, we're going to evaluate this a sub n. So that's 3n minus 5 minus the quantity 3n plus 2. All right. And in this case, what are we going to get? Well, so 3n minus 5 minus 3n, actually plus 5, not minus 5, minus 3n minus 2. Well, in this case, notice how these 3n's go away. And we're left with 5 minus 2, which equals to 3. So because in this case we get a constant, that means the difference between every single term, it's going to be constant, So what are we going to have here? So in this case, we're going to have we just proved that this is an arithmetic sequence with common difference d equals to the common difference is, well, let's actually first of all expand this with some elements of the sequence. So that's going to be 3 times 1. That's some of the elements of the sequence are going to be, so 3 times 1 is 3 plus 5. That's going to be 8. And then 3 times 2, which is 6 plus 5, that's 11. 3 times 3, which is 9 plus 5, that's a 14, and dot, dot, dot. So the common difference here will be, in this case, well, we already got that this is 3. D equals to 3. That's what we got. And then the first a sub 1, the first term of the sequence is 8. All right, so yeah, we found that d over here when we found the difference between a sub n and a sub n minus 1. But we still find, we still expand a couple of terms so we can verify that. All right, and so we can also look for the first term. All right, let's see what's next. What's on the next page? Well, finding a formula for an arithmetic sequence. Well, an arithmetic sequence is going to be one sequence whose first term is a sub 1 and common difference is d, and the nth term is defined by, or is determined using this formula. You know, we can use this formula to find, like, for example, the seventh term of a sequence, or the, I don't know, 45th term of a sequence. I mean, you don't want to write 45 numbers. So given just a couple of numbers, recognizing the pattern, identifying the common difference, and the first term of the sequence, well, in this case we have a1 equals to 2, and the common difference, which is, well, 6 minus 2, that's equals to 4, 10 minus 6, that's equals to, well, it's actually the same sequence as in the previous, it's in the previous page, you know, except for this, you know, some of the numbers, well, it's not the same, never mind. So d equals 4. So what are we going to do? We're going to use this a sub n equals a sub 1 plus n minus 1 times d, and in this case, for our particular case, well, a sub 1 equals to 2 plus n minus 1, that's the dummy variable here, n, and the common difference, which is 4. A sub n equals to 2 plus 4n minus 4, and a sub n equals 4n minus 2. So we are going to use this expression. We're going to use this expression to evaluate, to find the 41st term of the sequence. I mean, you don't want to go to keep adding 4 plus 4 plus 4, you know, to the next term, because, I mean, you don't want to do that all the way to the 41st term. So we're going to use this formula, the 41st term, a sub 41, equals to 4 times 41 and minus 2. So 4 times 41, and that's a sub 41 equals to 164 minus 2. So the 41st term of the sequence will be 162. You can verify that, of course, adding 4 and then 4 to the next term. You should get the same final answer, you know. So, but otherwise, I mean, we use the formula to do this quicker. A very typical example here, you know, like example 3, in this case, we're given two pieces of information, you know, like the 8th term of an arithmetic sequence is 75 and the 20th is 39. Let's find the first term and the common difference. So in this case, we're going to use the same formula, a sub n equals a sub 1 times d. All right. So in this case, the 8th term, that means a sub 8 is, n is 8 in this case. But what is this? What is the 8th term? 75. 75 equals to a sub 1 plus 7d. But notice in this case, we're going to have one equation with two unknowns. We need to find a second equation to combine and solve a system. But yeah, don't worry, I know systems of equations. This one is going to be really, really short to do. And then the 20th term is 39. That means a sub 20 equals, well, a sub 1, which we don't know, plus, in this case, n is 20, minus 1 equals to, times d. But what is a sub 20? A sub 20 is 39 equals a sub 1 plus 19d. So we can combine these two together, 1 and 2, and solve a system. Actually, let me put it down here. So that's 39 equals a1 plus 19d. And that's our second equation, if you will. Well, this one is really easy to solve by elimination if you think about it well. So let's multiply the second equation by -1, or the first one, it doesn't matter. Either way is fine. So we should get, in this case, adding the equation. So 75 plus 75 minus 39, that's going to give us a 36. And then, well, let me actually instead rewrite the system of equations. 75 equals a sub 1. The first one remains the same. And minus 39, negative a sub 1 minus 19d. Notice in this case, a1's go away. A1's go away, and 75 minus 39, that's going to give us 36. And 7 minus 19, that's going to give us negative 12d. And dividing both sides by negative 12, that's going to give us d equals to negative 3. So, well, yes, can the common difference be negative? Well, of course. In this case, think about the information that we're given. The 8 terms, one of the first terms is a big number. And then a very further term is a smaller number. So in this case, the sequence is a decreasing sequence. It's going from from larger to smaller, and that's dictated by the d being negative. And now, well, we can plug in this d equals to negative 3 in any of the equations. I'm going to use 2 here. So 39 equals to a sub 1, and we use that to find the first term of the sequence. That's a negative 3. And then what is that going to be? Well, 19 times negative 3. Well, let's use a calculator in this case. So 19 times 3, that's 57. 39 equals a sub 1 plus 57, and a sub 1 equals, actually minus, it's a negative. So 57 plus 39, and that's going to give us 96. All right, 96. Yes, we're getting a larger number because, well, the 8th term is a smaller number than the first number, So a sub 1 equals 96. And we have the two elements that we need to construct an expression for the nth term of the sequence. But in this case, we want to do the recursive form. Okay, go back to the previous page. Let's go back to the previous page and look at the definition of the recursive form for the arithmetic sequence. So a sub 1 is the first term, which is 96, and a sub n equals a sub n minus 1 plus d. A sub n equals a sub n minus 1 plus d. And in this case, well, a sub n equals a sub n minus 1 plus the difference, the common difference, which is negative 3. Let me erase that. That's supposed to be a 3. All right. Well. Okay, so that's a negative 3. All right. So this thing kind of broke, and so that's the recursive form. Letter C, we want an expression for the nth term of the sequence. And for the nth term of the sequence, we are going to rely on this expression, just like we did over here with a sub 1 and d1, which we already got it, So let's use this model again. So nth term, so that's going to be a sub n equals a sub n plus 1, oh, not plus 1, plus n minus 1 times d. And in this case, a sub 1 is equals to 96 plus n minus 1 times the difference, negative 3, which in this case is 96 plus n, oh, actually, never mind. A sub n equals 96 minus 3n, Negative times a negative, be careful, plus 3. So in this case, what are we going to have? We're going to have a positive 99. So negative 3n plus 99. That is, if we want to find another term of this sequence, like the 257th term, we'll plug in 257 to this expression to find that term of the sequence without having to expand the entire sequence. All right, so let's move on to the sum of an arithmetic sequence. Well, what do we know about the sum of a sequence? Well, that's basically a series. Every time when we have a sequence, we just list the numbers. But when we add those numbers, it's you can tell that by the sigma or by the summation symbol. So that's a series, and then we have to add all of them. All right. So the formula to add all the elements or the n elements, the n terms of an arithmetic sequence, say a sub 1 plus a sub 2 plus a sub 3 plus dot 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 a sub n. We use this formula. That is, we add a sub 1 plus the sum of the expression, and there's two ways to go about this form. Number one, either n over 2 times 2a sub 1 plus n minus 1 times d, or n over 2 times the sum of the first and the last term that we are going to add. So let's go over a couple of examples. So let's see. So find the sum of the sum Sn of the first n terms of the sequence a sub n equals 3n plus 5. So what are we going to do? S sub n, not a sub n, S sub n equals, it's going to be the sum sigma k equals to 1 and k equals to 1 to n, of the expression that we are given, which in this case is this 3n, or actually 3k. We changed the dummy variable, k plus 5. All right. So ultimately what we do, so what we're essentially doing is 8 plus 11 plus 14 plus dot 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 plus 3n plus 5. That's what we are doing in this case. Where do these numbers come from? Plug in k equals to 1. 1 times 3 is 3 plus 5 equals 8. 2 times 3 is 6 plus 5 equals 11. 3 times 3 equals 9 plus 5 equals 14, and so on and so forth. Well, in this case, to find the general sum, the sum of all the first n terms, we are going to do n over 2 times the first term, which is a sub 1, plus the nth term. But well, what do we know about the first term? The first term is 8, and the nth term is given by, in this case, 3n plus 5. And then combining this together, n over 2, that's a 3n plus 13. So this is the expression that we would use to find the first n terms. But what if we want, find the sum of the first, 67 terms. Let's say I'm going to go 8, 11, 14, and then the next all the way to the 67th term, And well, I'm not going to add 8 plus 11 plus 14 plus the next. So no. I'm going to use this formula to find S sub 67 equals to 67 over 2 times 3 times 67 plus 13. All right, and if we simplify this, well, let's use the calculator to simplify this expression. Well, so that's 67 over 2 times 3 times 67 plus 13, close parentheses, and see what we get. We get 7169. So that's the sum of all the 67 terms for this sequence in particular. All right. Okay, find the sum. All right, this is a very classical problem. They will just give you a random. Well, it's not really random. Of course, we're gonna find a pattern, and then they're gonna ask you to find. Well, of course, there we are skipping. Well, not necessarily skipping. So it is understood that the sequence goes from 60 all the way to 120 with a common difference. Of course, 64 minus 60, that's a 4. 68 minus 4 is 4. 72 minus 68, that's 4. So the common difference is 4. So there are two elements that we need in order to define the sum of a common difference. We need to know the first term, which in this case is 60, and the common difference d, which is 4. All right, so what are we going to do here? Well, in this case, in order to find the sum of all these numbers, I need to know, or we need to know n, that is the number of terms. All right, but in this case we have a plus dot dot dot, and that's not telling us how many terms are there in the series or the sequence here. So we need to figure that out first using the formula for a sub n equals a sub 1 plus n minus 1 times d. So a sub n, which is in this case simply a sub n. A sub n equals to the first term, which is 60, plus n minus 1 times the common difference. All right. So let's see. In this case, well, what are we? Oh, that's supposed to be a 4. That's the common difference. Okay. Well, in this case, this is the nth term. So the nth term, a sub n, the very last term is 120 equals 60 plus n minus 1 times 4. I'm not going to distribute the 4. You'll see why in a minute. So I'm going to subtract 60 on both sides of the equation to get n minus 1 times 4. That's going to give us 60, and then instead I'm going to divide both sides by 4 to get n minus 1 equals to 15, and n equals to 16. So between 60 and 20 with a common difference of 4, we have a total of 16 terms. So now we are good to go and evaluate the sum. S of n equals n over 2 times the first term plus the very last term. Well, in this case, the nth term. In this case, the nth term, that's the 16th term, you know. So we want to add the first 16 numbers on the sequence. So S sub 16 equals 16 divided by 2 times the first term, which is 60, plus a sub 16. But what's a sub 16? The 16th term is 120. That's the 16th term. And in this case, what are we going to get? Well, 180. 8 times 180. And that's final answer, 1440. Final answer. A very typical word problem when it comes to arithmetic sequence, you know, when you have like this type of construction in which you're putting tiles, you know, so every row of tile or every consecutive tile, I mean every consecutive row has maybe one tile less or two tiles less or three tiles less, well, depending on the design of the tile that you're building. Or for example, another, when at a movie theater or a theater of arts, for example, every consecutive row has maybe two more seats than the previous one. Well, in this case, that two more seats and two more seats, that's basically the common difference. And in this case, well, let's read this problem. A ceramic tile floor is designed in the shape of a trapezoid, 20 feet wide at the base. All right, so that's 20 feet, or there's 20 squares, and 10 feet at the top. So in this case, there's 10 squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then there's 20 here. The tiles which measure 12 by 12, but doesn't matter, the area of each tile, it doesn't matter. They're to be placed so that each successive row contains one fewer tile than the preceding row. So in other words, with this, one fewer tile, with that they're telling us that this is, you know, this is, that's the common difference. But we need to be very, very careful because the wording may have a huge impact on the sign of the number that we use for this. So it's important to, okay, let me double check on my notes here. So yes, so in this case, because it's fewer, okay, so a sub 1, well, the first row has 20 feet or 20 tiles, if you will. The common difference, so because every row towards the top, it's gonna have minus one tile or minus 1 feet, you know, because one tile is 1 feet. So let's see. So in this case, what do we need to know? In this case, we need to find the sequence a sub n equals a sub 1 plus n minus 1 times the common difference. So the nth term is going to be the first term, which is 20, plus n minus 1 times the common difference, which is negative 1. Be careful with the signs. A sub n equals 20 minus n plus 1. And in this case, negative n plus 21 is, in this case, the general term. All right. So in this case, well, how many tiles do we have? Or how many rows are we going to have? So we are going to count them. Between 20 and 10, we're going to have, I mean, between 20 rows, I mean, the row with 20 feet and the row with 10 feet, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I need to find a sub 11. And in this case, it's going to be 21 minus 11, that's a 10. All right. So now I need to, without counting them all, 1, 2, 3, 4, 5, 6, 7, 8. Well, of course, we're not going to count all of them like this. We're going to use the sum of the arithmetic sequence s sub n over 2, and a sub 1 plus a sub n. And in this case, s sub 11, it's going to be 11 over 2 plus, times the first term plus the 11th term. It's time to put numbers here as 11. Don't worry about the fraction here. It's going to go an integer, of course. This one is a kind of a weird number. So a sub 1, which is 20, and then the 11th term, which is 10. 20 plus 10, that's 30. 30 divided by 2 is 15. 15 times 11. So we have a total of 165 tiles. All right. And of course, an alternative is to count them all one at a time. Well, that's going to take a while. And this is a good place to quit. I'll finish this video now, and I'll see you in the next one.